What is going on, everybody? Got another video for you. This is statistics, and it's on trees and counting techniques, and not the kind of trees that grow in the yard. All right, so let's go ahead and get started. So it says consider the series of events E1 through E sub m, where N1 is the number of possible outcomes for event E1. N2 is the number of possible outcomes for event E2, and N sub m is the number of possible outcomes for event E sub m. Then the product N1 times N2 times N sub m gives the total number of possible outcomes for the series of events E1 followed by E2 all the way through E sub m. So basically what we have here, if you're looking for the number of possible outcomes of something and you have several different events, you just multiply the number of outcomes of each event together. So let's look at an example. It says Jill is in a nursing program and is required to take a course in psychology and one in physiology next semester. She also wants to take Spanish. If there are 2 sections of psychology, 2 of physiology, and 3 of Spanish, how many different class schedules can Jill choose from? Assume that the times of the sections do not conflict. And you know, if you're in college, that's a big deal, making sure the times don't conflict. So we're going to assume that's not the case. All right, so just like this setup here, it's the number of ways for event 1 times the number of ways for event 2 times the number of ways for event 3. So we can see here that for psychology, we have 2 different choices there. For physiology, we have 2 choices, and for Spanish, we have 3 choices. So it's just 2 times 2. This 2 here is for the number of sections for psychology. This 2 is for the number of sections of physiology. And then times 3, which is the number of sections for Spanish. And this is equal to 12. So there's 12 possible schedules. Okay. All right. So that's easy enough there. That's not bad. So what if we wanted to look at it and we wanted to get like a picture of it, a visual display of the different outcomes? Well, we can do this by using a tree diagram also. So let's suppose that we're going to pick our schedule. And so the first class that we're going to pick, the section that we want to be in, is psychology. So if we're starting our schedule here and we go here, we can either choose section 1 or section 2. This right here is for psychology. I didn't spell that right. This is for psychology. Okay, so we can either choose section 1 or we can choose section 2. So let's suppose we come up here and we choose section 1. Then from here, we have to choose a class in physiology. So we have 2 sections to choose from here. So this next section would be, I tell you, I'm going to abbreviate this. This is going to be the abbreviation for psychology, and then this will be what we use for the abbreviation for physiology. So we have 2 sections to choose from here. So we can choose section 1 or section 2. We can go to either one of those. Okay, so now let's suppose in our schedule we choose section 1 for psychology, section 1 for physiology, then we have to pick a Spanish class. So how many choices do we have there? We have 1, 2, 3 choices for Spanish. Okay, we can pick section 1, section 2, or section 3. Okay, now let's suppose we went section 1 and then section 2, and then for Spanish, we can come up here and we can pick section 1, section 2, or section 3. All right, and then the same thing down here. Let's suppose instead of choosing section 1 for psychology, we chose section 2. Bring this on down some. Then we have 2 choices for physiology, section 1 or section 2. And then the same thing here. For Spanish, we can go section 1, 2, or 3. 1, 2, or 3. And then same thing here. We can go section 1, 2, or 3. 1, 2, or 3. All right. And that's all the different ways that we can choose our classes. And you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 choices. You see that? There's all the different choices. So if you wanted to get a picture of everything, you can see you can have section 1, section 1, section 1 for each class. Or you can go section 1 for psychology, section 1 for physiology, and then section 2 for Spanish, or section 1, section 3, and so on. So it gives you a visual, of all the different possibilities there are. This one right here, when we just multiply them together like this, that just tells us how many different choices. But this, we can look at all the choices. So, you can look at this as section 1, 1, 1. See section 1 for each one, and then section 1, 1, 2, 1, 1, 2, and then section 1, section 3, 1, 1, 3, and so on. Okay, and then you can see we can go section 1, section 2, section 1, 1, 2, 1, and so on. And we can list all the different possibilities out from this tree diagram. So that they come in kind of handy there. Okay, the tree diagrams do. All right, so let's move along to the next one. So it says Lewis plays 3 tennis matches. Use a tree diagram to list the possible win and loss sequences Lewis can experience for the set of 3 matches. All right. So let's take a look at it. So when he plays the first match, he's either going to win the match or lose the match. That's the first match. And then we have to play the second match. So let's suppose he won the first match. Then for the second match, he's either going to win or lose it, win or a loss. And this is the second match. Well, instead of winning the first match, let's suppose he loses the first match. Then from here, he's either going to win or lose the second match. All right. And now, remember, he's going to play 3 matches, so let's do that. So let's suppose he wins the first match, wins the second match. Then for the third match, he can either win or lose the third match. So this is the third. And then same thing here. He can win the first match, lose the second match, and then he can win or lose the third match. Or we can come this way. He can lose the first match, win the second, and then he can either win or lose the third match. Or he can lose the first match, lose the second match, and then he's either going to win or lose the third match. All right? And so there's a tree diagram for that. And now it's easy for us to list out all the different all the different outcomes of the 3 matches. So let's write them all down. So he can win, win, win. So there's one outcome. Or he can win, win, lose, win, win, lose. Or he can win, lose, win, win, lose, win. or he can win, lose, lose, win, lose, lose, or he can lose, win, win, lose, win, win, or lose, win, lose, or he can lose, lose, win, or he can lose all three matches. And we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 different outcomes. All right. So, and that's all the different scenarios that we could come across are these 8 right here. And we can also see by this counting principle up here, we can see this that we went over here at the very first. We can see here that, okay, let's take the first match. How many different outcomes are possible for the first match? Well, there's 2. How many different possible outcomes for the second match? 2. So times 2. How many different outcomes for the third match? 2, because he can just win or lose, so that's 2. And so 2 times 2 is 4, times 2 is 8. And you can see there's 8 different outcomes, and that's what we got here, the 8 different outcomes. All right. So you can see the tree diagram really helps you visualize everything. All right, and then that counting, that multiplication principle up there, that just, like I said, it just tells you the number of outcomes. But with the tree diagram, it's easy to write down all the different outcomes. All right, so how about this one? Suppose there are 5 balls in an urn. They are identical except for color. 3 of the balls are red and 2 are blue. You are instructed to draw 1 ball, note its color, and set it aside. Then you are to draw out another ball and note its color. What are the outcomes of the experiment? What is the probability of each outcome? All right, so we're drawing 2 balls, okay? So let's make a tree diagram to look at this. So when we draw the first ball, we're either going to get a red or a blue ball. We're going to draw one of the two. This is on the first draw. And then when we draw our second one, we're either going to get a red or a blue. And same thing down here. See, this is just if we draw red on the first, then we go to the second, we're going to get red or blue. But we can draw a blue on the first, and then on the second draw, we're going to get a red or a blue. All right. Now, they want to know what's the probability of each outcome. All right. So the way we can do that, so remember, you're gonna multiply these probabilities. You're going to multiply. See, this is the second draw. So whatever the probability is on the first times whatever the probability is for the second. And then that's going to give you that probability. So let's fill out the probabilities on this tree diagram. So if I draw a red ball on the first one, what is that probability? All right. So it says, I'm going to just write this over here. I'll write this in a different color. We've got 3 red and we've got 2 blue. Okay, so just so I don't have to keep coming up here, and 2 are blue. So we know 3 balls are red, 2 are blue. All right, so let's fill out these. I'm going to get a different color to do that. All right. So what's the probability of drawing a red ball on the first draw? Well, there's 3 red balls and there's 5 total. So that's 3/5 would be that probability. That's the probability of drawing a red ball on the first one. Now, let's suppose I drew a red ball on the first one. What would be the probability of drawing a red ball on the second? Well, that would be what? 2/4. All right. So how did we get that? Okay. So let's look at this. So we drew the first ball and it was red. All right. And what did it say to do? It says You are instructed to draw one ball, note its color, and set it aside. So when we draw that first ball, we're putting it to the side. We're not putting it back in the urn. So when we draw that red ball out and set it aside, now instead of 5 balls in the urn, there's only 4. And since it's red, there's only 2 red ones in there. So that probability would be 2/4. Now, let's suppose that we drew a red on the first and a blue on the second. So what would be the probability of drawing a blue ball second? Well, there's 1 red ball out of the urn, so there's only 4 balls total. But how many blue balls are in there? 2. See, because the one we drew was red, so there's still 2 blue ones in there, so that would be 2/4. Now, what if on the first ball we drew a blue one? Okay, so we reach in there to draw the first ball and we draw a blue one. Well, there's 2 blue balls in there and there's 5 total, so that would be 2/5. All right, so let's suppose we drew a blue ball on the first one, then what would be the probability of drawing a red one on the second? Well, the ball that we drew out was blue, so that means there's still 3 red ones in there, but there's only 4 total because we set that one aside. And then what would be the probability of drawing a blue on the second? Well, if we draw a blue on the first, set it aside, there's only 4 total, and since it was blue instead of 2 blue ones, there's only 1 blue ball. Okay. Now, they want to know all the different probabilities. Okay. So, what would be the probability? Okay, what are they? Red on the first, red on the second. Red on the first, red on the second. That would equal 3/5 times 2/4. Okay, and that would be 3/10. So that would be that probability. Now remember, they want us to find the probability of each outcome. So we did the red, red. Now let's go red, blue. So the probability red and then a blue one. And I'm not writing all this out. This right here, you could read this as probability of red on first. Okay. And red on second. Okay. That's what we're looking for. Red on the first ball, red on the second ball that we draw out. But I'm just going to do red on the first, red on the second. I'm not going to write all this out. Okay, but that's what it means. Okay. So this would be red on the first, blue on the second. So red on the first is 3/5 times blue on the second, which is 2/4, and that would equal 3/10 also. And then, I don't know why I put an R there. That should be a P, probability of. So the probability, okay, so we did red, red, and then we did red, blue. Now what about blue on the first, red on the second? Blue on the first, red on the second. Well, blue on the first is 2/5 times red on the second, which is 3/4, and that would equal 3/10 also. And then what about the probability of blue on the first and blue on the second? Well, blue on the first is 2/5 times blue on the second, which is 1/4, and that would be 1/10 would be that probability. All right. So you can see that the tree diagrams, they can come in handy, and they're really not that bad to draw. Okay, All right, let's continue on with the video. All right, so we got factorial notation. So for a counting number n, all right, so we've got 0 factorial is equal to 1 and 1 factorial is equal to 1. And n factorial, so you need to remember these. And then n factorial is just n times n minus 1 times n minus 2 all the way down to 1. So what that means, they want us to evaluate 3 factorial. And so that's just equal to what factorial is 3 times 2 times 1, that's 6. And then let's just throw another one in there. If they wanted us to find 5 factorial, that's 5 times 4 times 3 times 2 times 1. You just multiply from that number all the way down to 1. And so that's what, 20, 60, that's what, 120. Okay, and you can see that the factorials, I mean, just think if they wanted us to find 20 factorial, you would have to do 20 times 19 times 18 all the way down to 1. And you don't want to punch all that into your calculator. So you can, on your calculator, you'll have a factorial button on there. If you have a basic scientific calculator, it just looks like an exclamation mark. So you can just type in 10 and then hit the factorial and it should give you the answer. And of course that's dependent, how you get to the factorial button. That's going to depend on what calculator you have. So I'm not going to go through the calculator part of it. You'll just have to maybe figure that out on your own. All right. So let's look at this example here. In how many different ways can 3 objects be arranged in order? Okay. So how in the world will we do that? We've got 3 objects. We want to arrange them in order. Okay, so that means we're going to have 3 spots to arrange the 3 objects. All right. So We've got 3 objects. Just say we got 3 objects over here. And I need to pick one of them to go in this first spot here. How many choices do I have over here? Let's say we've got object A, B, and C. These are our 3 objects. So how many choices do I have for the first spot? If I want to pick one of these, well, I've got 3 to choose from, right? So that's 3. And then for the second spot, how many choices do I have? Well, I only have 2 choices because I've already used one of them for the first spot. So I only have 2 choices for the second spot. And then since I've already used 2 of them, one in this spot, one in this spot, I only have 1 choice for the last spot. And so that's 3 times 2 times 1, which is 6. There's 6 different ways that I can arrange the 3 objects in order. Okay, which is basically 3 factorial. All right. All right, so let's look at this counting rule for permutations. So the number of ways to arrange in order n distinct objects, taking them r at a time, is permutation n choose r equals n factorial over n minus r factorial, where n and r are whole numbers and n is greater than or equal to r. Now, this is a notation for permutation. Another way you might see the notation for permutations is this. This is permutation n choose r. Permutation n choose r. I wrote this out. I was going to type it here, but I couldn't figure out how to get it to type with the subscript in front of the letter. I couldn't get it to work, so I just figured, well, I'll just write it down for y'all. But this is another notation you may see. All right, so here, this example, it says compute the number of possible ordered seating arrangements for 8 people and 5 chairs. Okay, so the number of possible ordered seating arrangements for 8 people and 5 chairs, well, that's a permutation. So how many people do we have? Now remember, n, that's how many objects you have. So in this case, we have eight people. And how many are we choosing? We're taking what? 5 of them. Okay, because we gotta, of those 8, we have to choose 5 to sit in a chair. So that's times 5. And so that's permutation 8 choose 5. So that's 8 factorial over 8 minus 5 factorial. Now, I wrote it out in the formula, but I don't know what your teacher's going to do. I know as far as I'm concerned, I don't make my students plug it into this formula. I'll work it out using the formula, but you can just punch these permutations in your calculator. Your calculator is going to have a permutation feature on it and a combination, which we'll do that right here, combinations and permutations. And keep watching the video because I got some more to explain about combinations and permutations, the difference between them. That's very, very important, so make sure you keep watching. So, you know, if your teacher makes you calculate this out by hand, an easy way to do it is this. So that's going to be 8 factorial over 3 factorial, right? So we can write this as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay? Or you can just leave that last one as 3 factorial over 3 factorial, and you can see those cancel. And so now you just got 8. You got 8 times 7 times 6 times 5 times 4, and that would be 6,720 different arrangements. Or you can punch this into your calculator, which I know you can't see it, but I'm doing it right now. So I just punched in 8 permutation 5, and I get the 6,720. So learn how to do it on your calculator. I do have videos on my channel. You can search my channel. It's how to do combinations and permutations on a calculator. Just search my channel for that. And I think I have 2 different calculators. I've got the TI-30X2S, and I think I do a TI-84, something like that. But I go through showing you how to do combinations and permutations on that. All right. All right, so now, and like I said, we're going through permutations, and now let's look at combinations. And then after I work this example, I'm going to explain to you the difference between them, because that's very, very important. All right, so now we've got counting rules for combinations. The number of combinations of n objects taken r at a time is combination n choose r is equal to n factorial over r factorial times n minus r factorial. So notice the formulas are a little different. In the combination, we have r factorial down here in the denominator also. Okay, where n and r are whole numbers and n is greater than or equal to r. And once again, there's different notations for combinations. So another notation you may see for combinations is this, combination n choose r. And then another one is this. You may see this notation for combination. All right. All right, so let's look at an example. So basically, you've got n objects, and how many of those objects are you choosing? So it says in your political science class, you are assigned to read any 4 books from a list of 10 books. How many different groups of 4 are available from the list of 10? All right. So here we have a combination. I have 10 books total, and I'm choosing 4 of them. And so this is going to be 10 factorial. See, n r, see, n is 10, r is 4, over 4 factorial times 10 minus 4 factorial. And so this is 10 factorial over 4 factorial times 6 factorial. And so for this, we would have 10 times 9 times 8 times 7 times 6 factorial I'll put the factorial here, and then that's 4 factorial times 6 factorial. And you can see the 6 factorials. They cancel. And then this would be 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. So you can see the 4 and the 2, that add up to 8, and that'll cancel with that. And the 3 and 9 will cancel, and that'll cancel there. So that's going to be, what is that, 210? I think. I just did that quick in my head. Don't hold me to it. I'm punching it in my calculator to check. So let's see. And yes, that's 210. All right. So, if your teacher makes you put it in the formula and stuff, just write it out, start canceling things out, and it makes it a little easier to punch in your calculator. But like I said, calculators, basic scientific calculators, they're going to have a built-in feature for permutation, combination, and factorial. Just learn how to use those. Okay, so let's get to the good stuff. Now, we've worked 2 examples. One was permutation, one was combination. Okay, so the big question, why in the first example did I use permutation, and why in the second example did I use combination? And it's not because this example was under permutation and this example was under the combination formula. Okay, so let's look and see. So the difference between the two. With permutation, the order makes a difference. With combinations, the order does not make a difference. Notice it says here, compute the number of possible ordered seating arrangements. Okay? So, that has something to do with it, why it's a permutation, but it's not always going to tell you ordered in the problem. Okay? So, let me just talk you through an example real quick that I think is going to really get you to understand the difference between the two. So let's suppose I have 5 books. Okay, I've got, let me do this in a different color. All right, so suppose I've got book A, B, C, D, and E. Okay, 5 books. And I say, okay, I want you to choose 3 books to arrange on a desk, on a shelf. I want you to pick 3 of these 5 books to arrange on a desk. Well, that's a permutation. That's permutation 5, choose 3. I have 5 objects. I'm going to choose 3 of them. And let me show you why. So let's suppose I choose book A first, book B second, and book C third. That's one arrangement. Now, let's suppose I choose book B first, book C second, and book A last. I chose the same 3 books, but the order that I chose them is different. And this is a different arrangement. See, this arrangement is different than this one. But I chose the same 3 books. So the order that I chose the books in made a difference. So that's a permutation. Now, let's suppose I have the same 5 books, and I need to get rid of some of them. So I'm going to choose 3 books, and I'm going to give them to you and say, go throw these away. Okay? So let's suppose I chose book A, B, and then C, and I said, go throw those away. Or let's suppose I chose book B, C, and then A, and I gave them to you and I threw them away. Did that make any difference? No, it made no difference. I just gave you, I chose A, B, C, go throw them away. Or if I choose B, C, A, I say go throw them away. That order made no difference. That's a combination. Okay? A good example of combinations is the lottery or the Powerball. What does the Powerball do? They choose 5 numbers, right? Does it matter what order they choose the 5 numbers for you to win? No. You just got to have those 5 numbers. It doesn't matter what order they're chosen in. That's a combination. Okay? So remember, permutation, the order matters. Combination, the order does not matter. All right? All right, now let's look at these last, I think this, yeah, we got 2 more examples. All right, so these are combination and permutation. We don't know which one's which. See if you can decide which one's which. Okay, as I read the problem, it says the board of directors at Belford Community Center has 12 members, 3 officers. President, vice president, and treasurer must be elected from among the members. How many different slates of officers are possible? So is that a combination or permutation? Okay, so I've got 12 people. Okay, so let's suppose, okay, let's just give them names. A, B, C, D, E, F, and so on. Okay, I'm not going to write out 12 letters. But these are your 12 people. These are their names. Okay. So if I choose, and I need president, vice president, and treasurer. So if I choose A first, and then B second, and then C third, that's one arrangement. That means A is president, B is vice president, and C is treasurer. But I could also choose B first, A second, and C third. That means B is president, A is vice president, and C is treasurer. See, the order that I chose them made a difference. It's a different, different president and vice president. But I chose the same 3 people, but the order that I chose them made it different. So this is a permutation. This is permutation 12 total members, and I'm choosing how many? 3. And I'm not going to write out the formula for this one. I'm just going to plug it into my calculator. So 12 permutation 3, that would be 1,320 different possible ways, different slates of officers possible. All right, so now we got 3 members from the group of 12 on the board of directors at the Belford Community Center will be selected to go to a convention in Florida. How many different groups of 3 are there? Okay, so we're using the same information, but they're asking a different question, aren't they? So I've got the 12 members over here, and I need to pick 3 of them to go to a convention. So if I pick A, B, C, and I said, y'all are going, is that any different if I pick C, B, A, and said, y'all are going? No, it's the same 3 people. The order made no difference. So that's a combination of 12, choose 3. And let's look at the difference we get in the number. Combination 12, choose 3. Plug that into our calculator. So there's only 220. The combination gets those duplicates out. Okay. So that is the video on trees and counting techniques. I hope it all made sense. Check out my other videos. I appreciate you watching. Give me a like, share, comment, subscribe, and I will see y'all in the next one. Later.